Okay, so this is Unit 1.1 and this is video B, and this video is going to basically just focus on identification of degrees and like terms and some of the things that we've been using before. Now, in the last video you were shown how to simplify, and we're going to use that skill to be able to help us do identification, because there's one thing that we have to do before we start to identify, and that is to simplify. So we need to make sure that we use that skill. So if you haven't watched that video, please watch that video first, so that we can go ahead and we can identify expressions. So the first thing that we're going to look at is the degree of an expression. Now, the degree of an expression is basically the combined exponential value of a term. Now, I highlighted or underlined this word term because it's just one piece of an expression. It's not the entire thing. And so the idea is each term has its own value. And we're talking about exponential value. So it's kind of like the total, what we would call the total exponents. And so you have to look at all the variables. You have to look at all the exponents. You basically just add those together, and it's going to be kind of a basic, easy term to remember, but there's a couple of things that we have to do first. So when we look at something like this, we have 9x squared minus 5y to the third x squared, and we have plus 8. And one of the things that we have to look at is 1. We have 3 different terms. So each one of these things that I'm underlining here, these are all individual terms. Now, each one of these terms has their own degree, and I will tell you this right now. This is term 1, this is term 2, and this is term 3 here. So as you kind of go along, this is 1, 2, and 3. And so the idea of what we're looking at is then we can talk about, we look at exponents, or not the exponents, I'm sorry, that's not an exponent. That is our coefficient. So the idea is that the numbers in front are kind of what we manipulate with, where then we have our variable portion that gives us whether things are the same or not the same. And so the idea is that when we look at degrees, this one here, 9x to the second, has a degree of 2. 5y to the third x to the second has a degree of 5, and 8 as itself has a degree of 0. So numbers, I will just put this here, numbers by themselves have no degree. The only thing that has degree are basic variables. And so the idea is that when we talk about the total exponential value, x to the second has an exponential value of 2. We have y to the third has an exponential value of 3. X squared has a value of 2. We add those things together, and that's how we get a degree of 5. And so basically you're just counting the exponents to find the degree. And that's really all that we're doing here, is finding these degrees of each one of these terms. And so in order for us to identify, is we need to make sure that things are simplified before we identify. So we're going to put a little asterisk up here. Unless things are in its basic form, you cannot identify them. So we need to make them in their simplistic form. And so just like we did, or just like I showed you in the other video, we're going to go ahead and identify like terms. Now, if you just recently watched this video, you might be very familiar with kind of the setup here. So we have x to the 8th y is 1. We have negative 14 is negative 14x y to the 8th, which shares a like term over here. And then I'm going to do a curly bracket for this one to show that we have our pairs here. We're going to go ahead and simplify. So 14x to the 8th y minus 14 plus 14, that gives us plus 0xy to the 8th. And then we have plus 14x to the 8th. Now the idea here is that we have a term that equals 0, so we can go ahead and get rid of that. But it's important for me to show you that those do equal 0. They're just not disappearing. And so we have 14x to the 8th y plus 14x to the 8th. And so when we do a couple of things when we talk about identifying, so what we want to do is, one, we want to identify the degrees of each term, so the degree of each term. And the second thing that we like to do when we identify is we want to talk about the number of terms. And so when we look at something like this, this expression right here has two terms. We have the 14x to the 8th y, and we have 14x to the 8th. Those are two unique terms. And then the second thing is we want to identify the degree. So we're basically just going to count up the exponents. So in this one, you would think that the degree is 8. However, we're talking about each variable and how it's represented. And if you remember from Algebra 1, these variables all have a hidden 1 for their exponent. So the degree of this term is 9, and then the degree of our second term is 8. And so if you remember, exponents are the only thing that add to the degree. The numbers themselves contribute nothing to those degrees, so we just have to make sure that when we're looking at this, we're identifying just the exponents and what they contribute. And then the last thing, just remember, like anything else that we have, that we need to simplify before we identify. In order for us to identify these things properly, they do need to be in simplest form, so we always need to simplify before we identify. Okay, so if we look at this next example, we're going to determine the highest degree, and then we're going to determine the number of terms of this expression. So again, in order for us to do this, we need to simplify before we identify. So we're going to just go ahead and look for any of our order of operations. So first, we look at the set of parentheses over here and say, well, we're going to need to distribute this. So we're going to go ahead and distribute the entire thing, which is that -10. So we have 210 p to the second r minus 10 p to the second, and then minus 10 r to the second. Notice how that subtraction and that negative kind of carries with it. It just doesn't go away after the first time you do it. And so now we're going to identify if we have any like terms. So we have p squared r, and we have a p squared, and we have an r squared. So we don't really have any like terms, so we don't need to do any simplification. The only thing that we had to do here was distribute, and then we were done. So the idea is that we have 3 terms. So I'm going to write over here, we have 3 terms. All of them are unique with their variables. And then we're going to determine the degree. So again, the only thing that contributes to this is the variables, has nothing to do with the numbers. We're going to write any hidden exponents that we have. So we have an exponent of 1. So 210 p squared r has a degree of 3 because we have basically a p squared and an r. So we have 3 total variables that are part of this that term. This one has a degree of 2 because we just have a p squared, and then this last one is r squared, so that also has a degree of 2. And so our highest degree term is actually this guy right here, and so that will be important a little bit later in this class when we talk about degrees, because with that being the largest degree, it kind of dictates the way that things are going to happen. And as we start plugging in numbers, that will kind of be the main term that will kind of dictate what these values will end up being. And so basically, again, as you go through the steps, we're going to simplify before we identify. We're going to identify our number of terms after we do that, and then we're going to identify the degree and just kind of identify which term has the largest degree. And so we have one more here. So if you haven't already or you want to give it a try, why don't you go ahead and do this one. You can go ahead and pause the video, and then I'll give you a second to go through that and try to do this one on your own. Again, just follow these 3 kind of guiding steps there to see what you have. So if you haven't already, go ahead and pause that and see if you can come up with an answer of those kind of 3 questions, what your final simplified answer would be, and then how many terms and what's the highest degree. Okay, so basically what we're going to do is we see parentheses. We always look to try to distribute. Since that negative is after, we're not going to worry about that. That kind of stays with everything after. So we have 1,000 that needs to be distributed. So distribute here, distribute there. So I have 1,000x plus 7,000 minus 2x. So now I can just start writing stuff. And then plus 550x. start looking at what are my like terms. I have a variable of x and a variable of x. Again, notice that this x squared is different because it has an exponent of 2. I'm not going to do anything with those. And then I have 7,000, which is just a plain number. And so I'm going to go ahead and write those. So I have 1,000 plus 550. So that's 1,550. And then the x comes along with it. Doesn't disappear, doesn't do anything. It just kind of goes along for the ride. Plus 7,000. And then I can write minus 2x squared. Now the reason that I kind of incorporated that is because you need to make sure that that x squared term stays negative, because that negative 2 is associated with it. And so here's our simplified answer. We have 3 terms here because there are 3 unique different things here. We have an x squared, an x, and just a number. And then so when we look at degrees, again, this has a hidden exponent of 1, so the degree on this value, or this term here, is 1. Numbers have a degree of 0, so that one is kind of just 0 for 7,000. And then we have a degree here of 2 because our exponent is 2. And so our highest degree term here is actually this negative 2x squared. So the idea here is just go through, simplify, and identify what you need to as far as highest degree and number of terms. You have Alright, so the last thing that we need to look at is just a factor, and this is kind of where the degrees come from. So when we talk about factors, factors are just pieces of multiplication. And so when you look at factors, you just kind of break down numbers in terms of what is around. So when we look at this term right here, so this is all just one term. And so when you look at one term, you break it apart into kind of the different pieces. First of all, the number itself, so you have 35, and then you have multiplied with y to the third and multiplied with x to the second. So what makes a term is it's just a chunk of multiplication. And so when we talk about factoring, we're talking about the pieces of multiplication that make up that one term, and kind of below that, kind of what are the pieces that make up those individual pieces. So the idea of factoring is taking a term and kind of breaking it down into its smallest pieces. So it's kind of like taking water in it, for an example, and breaking it down into its different molecules, and then breaking it down into its different atoms. So we're basically going to do that with terms. And so when we look at numbers, something you might be familiar with is prime factoring, where you basically take a number and talk about what prime numbers make up that number. So 35 is 7 times 5. And when you look at y to the third, it's really just y times y times y. And that might seem, common sense to you, but the idea is that we're looking at, what each one of these pieces contributes to the entire term. And then x times x would make up x squared. And so when you look at it, this right here, this is what contributes. So contributes to the degree. And if I was to tell you this term right here has a degree of 5, and if you think about it, there are 5 different variables that are represented. Y is represented 3 times, x is represented 2 times, therefore it has a degree of 5. So when we're looking at factoring, we're just kind of looking at breaking it down until its smallest pieces so that we can see what eventually what we can do is we can look at what they have in common with other terms and how we can simplify even more based on this kind of idea here. And so we can kind of just talk about briefly the basis of numbers and simplification. Simplification is the idea is that we're trying to get to an answer. And so when we look at simplification, we want to try to get an answer or we want to get an expression based on lowest values. And so you try to break it down into the smallest pieces, try to combine what you can, where factoring in this kind of different idea, when we're looking at the basis of numbers, factoring kind of looks at what makes up an individual piece. And so simplification is trying to get kind of the most generic, most simplified answer as much as possible, where factoring kind of breaks apart a term to kind of look at its internal components. So simplification is about getting rid of stuff. Factoring is just keeping everything that you have, but just kind of breaking it apart so that you can see inside of it. And so that's going to do that that's going to do it for this video about identification of expressions.